All right, everybody, I am redoing the guided problems for you. It looks like the last time I made them, I did not share my screen, so it was just me talking through the whole thing, which I'm sure was amazing. But anyway, so I'm going to go ahead and redo it. So here we go. First one is they want us to see if there is a relationship between the demand of some digital cameras and the price of them. So I'll just start by opening it in Excel. Maybe. There it is. All right. So to see if there's a relationship between the X variable and the Y variable, all we're going to do is it's asking us for a correlation coefficient, and Excel has a formula or a function for that. It's equals CORREL array 1, comma, array 2. And that will give us the correlation coefficient. This one happens to be negative 0.874. What that means is that, remember that correlation coefficient runs between -1 and +1, and so if we had a perfect negative correlation, it'd be a -1. A perfect positive correlation would be a 1. So what this tells us is that this is a pretty strong correlation, and that it's negative, meaning that as price goes up, demand goes down. Okay, that they are inversely related. Anyway, so I'm gonna check that. It tells me I'm good, and we'll move on to the next problem. So here we have a set of ordered pairs, which I will open in Excel. And it wants us to calculate the coefficient of determination. And then test the significance of that coefficient of determination. All right, so what I'm going to do to calculate this is I'm going to use data analysis, and I'm going to click on regression. Then I've got to tell it which items to look at. So for Y, I'll choose all of the Y items. For X, I'll choose all of the X. Because when I highlighted, I included the labels X and Y, I'm going to click labels so it knows that this top row are labels and not numbers to look at. And then output range is just where I want it to put the summary. I'll put it here at D9. I'll hit OK, and it will give us this summary output. And one of the things it gives us is the R squared. You can see right here it's labeled R squared. So that's the answer. That is the coefficient of determination for the sample. Okay, so that is 0.903. That's our coefficient of determination. So the next thing it wants us to do is test the significance of the coefficient of determination, meaning how, can we determine from this coefficient of determination if the population coefficient of determination, or if the population is likely related in the same way that we think the sample X and Y are related. And so anytime we do this, we're always going to have the same null and alternative hypotheses. So the null hypothesis is that our population coefficient of determination is, let's see, is less than or equal to 0, and that the alternative hypothesis is greater than 0. What this means is that if our coefficient of determination is less than or equal to 0, that means there's no relationship between things. Think about it. We already figured out that our R from the last problem, our correlation coefficient, was between 1 and -1. So the R squared is always going to be positive. So as it approaches 0, that means there's just no relationship between things. So our null hypothesis is that there's no relationship, and our alternative hypothesis is that there is a relationship, or that our coefficient of determination is greater than 0. And that's always the same anytime you're doing any of these correlation of or coefficient of determination things. So in order to test this now, we're going to have to come up with a critical score and then a test and see how it compares. Coefficient of determination uses something called an F distribution. We've learned about normal distributions where we use Z, and T distributions. So an F distribution is another type of distribution. And so we can do f.inv.right.rt, which is for right-tailed, because really only testing is it bigger than this, okay? Our probability, 0.05. And then it asks for 2 different degrees of freedom, degree of freedom 1 and degree of freedom 2. And we haven't learned a lot about this yet, but each time we break these down, we have our degree of freedom for regression and our degree of freedom for our error, which Excel calls the residual, okay? So all you need to know for now is that we're going to put 0.05, or our significance level. Our first degree of freedom is our regression degree of freedom, given to us here as DF1, and then our second is our residual or error degree of freedom. And that's going to give us our critical F score, which is be 10.128. Now, there is a formula in the book for calculating the T statistic if you want to calculate it. I'm sorry, the F statistic, or we can come right here, and it's actually given to us. So here it is, the F statistic is 28.039. All right, so the way this works is if our F statistic, or our F score, is greater than our critical F, then we're going to reject the null hypothesis and conclude that it appears that there is a relationship between the data. So in this case, F is greater than the critical F, so we will reject the null hypothesis because there appears to be a relationship between X and Y. And that's it. All right. Well, that's it for that problem. Not that's it, because the next 2 are going to kind of stink a little. Not because they're crazy hard, but because there's kind of a crazy big formula that we're going to have to put into Excel, and that can be challenging. So first thing I'll do is open it in Excel. And then I'm going to need some data. So it says, consider the set of ordered pairs shown below, assuming that the regression equation is y hat equals 3.999 plus 0.167x. The SSE is 5.0. Construct a 95% prediction interval for x equals 4. So you can look up the formula for the prediction interval in your book, or you can look it up right here in View an Example, and it gives us the formula right here. To make my life a little easier, I sometimes take my snipping tool and I just copy that little formula right out of there, hit Control-C for copy, Control-V for paste, and now I have my formula right here that I can refer back to in Excel. So that's the formula we're going to have to deal with, which means we're going to need each of these variables to calculate the prediction interval. So what I'm going to do is I'm just going to come over here and I'm going to say, okay, I need y hat. That's the y with the little hat on it. That's really what it's called. I'm going to need my critical T. I'm going to need my standard error, or SE. I'm going to need N, X, X bar, the sum of X squared, and the sum of X. Okay, so what do I already have given to me? Well, I already have X, which is 4. And I already have, is that all I have? That's what I have. That's all that's given to me. So oh, I have n as well. So that's the number of ordered pairs. So I can look and see there's 5 of those. So I have n. And now I can start figuring out the things I don't have. So y hat is the expected value of y for a given value of x. So if this is the formula for y hat, then I can find it by doing 3.999 plus 0.167 times x. So if x were 4, then we would expect y hat to be 4.667. Okay. My critical t, this is a two-tailed t-test, so equals t.inv.2t for a 95% interval, confidence interval. I'm going to put 0.05, 1 minus that, right? And then for degrees of freedom, I'm going to do n minus 2. So there's my critical t. To find my standard error, I can do the formula, or I can come up to data, do data analysis, regression, choose my y range, my x range, tell it where I want it to output, and hit OK. And then my standard error will be right here, standard error. Some people like to just do equals that cell, so they have it all together. Some people will just use this when they get to building this formula. X bar is just the mean of all the x values. So I'm going to do this equals average of x. The sum of my x squared values, to do that, I'm going to actually have to make another column, call it x squared, and then say that equals the value of x squared. Do that for each of them. So we're squaring each of those x values. And then this is the sum of all those x squared values. And then the sum of x is just what it sounds like, the sum of all the x values. Okay, so we have all of the information we need now to calculate our prediction interval. And so if you remember from earlier chapters that we have some base amount, which is our y hat, our calculated or expected value of y for a given value of x. And what we're saying is, okay, we predict that that's what the value of y will be, but we want to have a greater confidence in that prediction. So in this case, we want a confidence of 95%. And so what we're going to do is we're going to construct an interval with an upper limit and a lower limit around this prediction to give us more confidence that the true value of y will fall somewhere within that range. That's all we're doing here. So it's the y hat plus or minus a margin of error. And the margin of error in this case is our critical t times our standard error times all of these items that are inside of the square root, the radical here. Okay, so margin of error equals critical t times standard error times everything in this square root. So the square root of 1 plus 1 over n plus x minus x bar, x minus x bar squared, there's the numerator, divided by the sum of x squared minus sum of x squared divided by n. So that's our margin of error. That Excel formula is pretty crazy, but it's pretty doable too. So there's our margin of error. So now our upper prediction limit will just equal our y hat plus our margin of error. And our lower prediction limit will equal our y hat minus our margin of error. So now we're going to say we're 95% confident that if we have an x of 4, that our y hat will be somewhere between 0.12 and 9. That seems like a really huge range, and I don't know how helpful it is to us. Let's see if I got the answer right, or if I, make sure I didn't make a mistake. 9.209 and 0.125. Okay, all right. So the next one is similar. Instead of a prediction interval, or prediction limits, we're going to do confidence limits, which actually have less error. It's the same formula, except it won't have this 1 in here. Okay, so again, this one is about if a team scores a certain number of points, how likely are they, or how many games do we think they'll win if they average a certain number of points. Let's see. So let me open it in Excel. Same thing, I'll come up here to question help, and I will get my formula. I'll snip it out so that I have it for easy reference. Paste it in there. Now, same thing, I'm going to go through and say, what do I need and what do I already have? So I'm going to need y hat, I'm going to need critical t, I'm going to need the standard error, n, x, oops, x bar, sum of x squared. Same stuff, right? Same thing I needed for the last one, sum of x. All right, so again, what do I know already? Well, I know that x is 24. And I know that with a confidence interval of 90, then my critical t is going to be equals t.inv.2t of 0.1 with n minus 2 degrees of freedom. This is going to come up with an error because I haven't put my n in there yet. But it's easy for me to see what my n is. I have 8 ordered pairs. So there's my n. All right, and the rest of this stuff I'll have to calculate out. So in order to do that, I'm going to come to data, data analysis, click regression. My y range. Let's see, this one's a little harder because it doesn't tell us what x and y are, so we have to use our brains and figure it out. Remember that x is our independent variable. Okay, so the number of points we score in a game we think is going to impact the number of wins we have. So x is the independent, the number of points, and then y is going to be the number of wins we have, or the thing that is impacted by the number of points we score. Choose where we want our output range and hit OK. So there's our output. So our standard error is right there. X bar is going to be the average of all the values of x. And the sum of x squared, again, I'll have to make an x squared column here. I'll say it is x squared. Set it up. So equals the sum of all of those x squared values. And the sum of x equals the sum Finally, y hat. So in the last problem, it gave us a little formula to solve for y hat. It doesn't give us that in this one. But if we look here, where it tells us the intercept, and this says points per game, but that's actually the slope, okay? It's just pulling off of our things here. We can figure it out. So we're going to say that y hat equals the intercept plus the slope times x. Again, that's the expected value of y. So what we're saying is if a team scores 24 points, we expect that they're on average, then we'll expect they'll win about 9.3 games in a season. So now we're going to build a confidence interval around that by calculating the margin of error and then adding that to y hat, subtracting it from y hat. So my margin of error equals a critical t times my standard error times square root of 1 over n plus the numerator, which is x minus x bar squared. That's the numerator, divided by the denominator, which is the sum of x squared minus the sum of x squared over n. There's our margin of error. That seems freakishly large, which means we probably have a mistake in there, right? So let's take a look at that again. Let's see. We have our critical t times our standard error, and then times the square root. Oh, wait. So even that seems pretty crazy, right? I mean, we just, oh, that's too big. So I'm going to actually redo this whole part. Sorry for you guys, but something's goofy there. All right, so we're going to say times the square root of I think I just forgot a parenthesis, 1 over n plus x minus bar x, or x bar I should say, squared divided by sum of x squared minus sum of x squared over n. That looks more like it. So we'll say our upper confidence limit is equal to y hat plus the margin of error, and then our lower confidence limit is equal to y hat minus the margin of error. So we are 90% confident that when x is 24, you're going to win between 6.8 and 11.8 games. So 6.813. I'm not sure why we're rounding it out to 3 decimals when honestly you have to round to a single game, right? 11.811. And Now, what did I do wrong? It says both of my answers are incorrect. All right, let's see if I can figure out my mistake, and maybe you can learn from my mistakes. Oh, you know why? Because I put the lower one in the upper one and the upper one in the lower one. That was dumb. Is that right? All right, fantastic. All right, I hope that helps, and I hope you're able to get this done. Don't be afraid to reach out for help. I will be available Friday, and actually I have some time tomorrow too if you want me to go over something with you.